Now that we've covered the first equation about acceleration, now we're ready to move on to the second one. And like the first one, this equation also requires calculus to derive. You don't need it to understand it, but it's a little hard to prove without calculus, so you're going to kind of have to take my word for it. But what you'll see is that this equation gives you the same result as the other equation. And what this equation does is it relates velocity, acceleration, and position. And says that the velocity squared was the original velocity squared plus twice the acceleration times the change in position. So, for instance, if you throw a baseball 10 meters up in the air, the acceleration is the acceleration due to gravity, which is approximately negative 10 meters per second squared. And it's negative because it's going down. Then the velocity at the end is the same as equals velocity original squared plus 2ax. And at its peak, velocity equals 0. So now we should be able to figure out what's the original velocity. So we can go through, we say 0 squared equals velocity original squared, because we don't know what it is yet, plus 200. Sorry, minus 200. And it's 200 because it's 2 times the acceleration is about 10 times the position is 10. So we add 200 to both sides, take the square root, and we end up with 10 square root of 2 is the original velocity. Well, the original velocity is about 14 meters per second. So this kind of showcases the power of this equation. If you know any three things in this equation, you can use it to find out the fourth. And this is very, very useful because a lot of times you want to either know how far something flies, or how high it goes, or how much velocity you need to get it to a certain height. And this equation can tell you that. And if you want to do that, all you have to do is write out your four different variables: velocity final, velocity original, x, which is change in position, and acceleration. And when something's interacting with gravity, acceleration is almost always either negative 10 or negative 9.81 meters per second squared, of course. And this depends on how exact you're being. Negative 10 is good enough for a lot of different things, but if you want to be exact to a couple more significant figures, negative 9.81 never hurts. And then, almost always, either the velocity at the beginning or the velocity at the end is going to be 0. And why is that? That's because when you throw something up in the air, in the moment before it stops going up, it starts going down. For a moment up there, the velocity is 0. It's neither going up nor coming down. It's just hanging in midair. And as a result, if we're taking a problem, we start by throwing it in the air, then velocity final equals 0. If it starts up in the air and begins falling down, then velocity original equals 0. So one of these is often equal to 0. It's not always true, but a lot of times it is. And that'll make your life a lot easier when you're trying to do this kind of problem. And then finally, change in position. In a lot of the problems you'll see on this, either you're trying to calculate how far something changes position, given a certain change in velocity and a certain acceleration, or given some change in position, you calculate the others. So write out the three that you know, plug them in the equation, solve for the fourth one. We can do a quick example to show that both of these do the same thing. For instance, if a brick is dropped off the top of a building and it falls until it's going 20 meters per second, how fast will it be going? So how far will it be going? We already know how fast it's going. And the way we do this is for the one, we say velocity original equals 0. Velocity final equals 20 meters per second. The acceleration is 10 meters per second squared, and it's negative because it's down. And for all intents and purposes, the 10 is close enough. And finally, x is what we want to know. So this is using the v squared equation. So for this, we just plug and chug. 20 squared is 400 equals v naught squared, which is just 0, minus 20 times x. That's 2 times negative 10 times x. Divide both sides by negative 10, and we end up with negative 20 equals x. So divide both sides by negative 20, and that makes sense. It fell 20 meters. So now let's try doing the same thing with the other equation. We know that velocity is acceleration times time, and our final velocity is negative 20 meters per second, because it's downwards, equals negative 10 meters per second squared times time. Divide both sides by negative 10, you end up with 2 seconds equals time. So the time's 2 seconds, so we can plug this into the equation. X equals x naught, it starts at 0, plus v naught times t, plus 1/2 at squared. And it starts at rest, so this is also 0. So all we have is 1/2 at squared. So x equals -5 times 2 squared, which is 4. -5 times 4 is -20. So both equations give us the same result, which is good, because both equations need to give us the same result if they're both right. And from this, we can at least start to see that both equations do the same thing. They just do it with different degrees of usefulness.